Hi, let's look at this question. In this question, I'm going to introduce a concept of inverse function. Okay, one of the properties of inverse function. So, if you, as you know that the inverse of a function, let's say you have a function that mapping an x by a function f onto a function. This will be your fx, right? This will be your value of y, which will be the image of this, right? So as you reverse from this back to the object, this is called the inverse function, right? So means that the inverse of the fx, the inverse of the fx here, it will produce x, right? So means, or we can say that the composite of fx will be x, right? So if this 2 is the inverse to each other, means that you were getting an x. Or this is also true if you said f inverse, you're getting the x, right? So means that if f inverse of x and the composite of f inverse and fx, you are getting an x, right? So okay, I will go through this question and will tell you about this is the properties of the inverse and the function itself. So okay, let's look at this question here. So determine whether the fx and gx, determine whether, tentukan sama ada fx dan gx are inverse of each other, adalah songsang kepada antara satu sama lain, by computing their composite function. So if this is the inverse of each other, the composite function of f and g will produce x, right? Okay, let's see. Okay, let's try. So let's find fg, right? The composite function of fx and gx will be f gx, which will be f and gx as your input, right? Your input. So you have f. What's your gx? Gx you know to be 5x plus 1, right? 5x plus 1 over 2x minus 3, right? F gx. And the gx you're going to put into f here. So means the x here you're going to replace with all this, right? So means you're going to, okay, write bigger a bit. So you will have 3 bracket plus 1 over with 2 bracket minus 5. So means this one you're going to put into the f, right? Into the function f here. So you're going to replace the function, the x here, with 5x plus 1 divided by 2x minus 3. 5x plus 1 divided by 2x minus 3. Alright? So then this looks like very complicated. The best way of solving this will be, you want to eliminate the 2x minus 3. So the best way will be, you taking up and down, multiply with the denominator, right, of one of the fraction here. So 2x minus 3. So because you want to eliminate the 2x minus 3, so that is easy to calculate. So you're going to expand this inside here, right? If you see carefully that 2x minus 3 and 2x minus 3 will be cancelled off, right? So on top you will have 3, 5, 15x plus with 3. And this one is already cancelled off, right? So and this one you have 2x minus 3. It's a lot easier, okay? You have skipped most of the step if you're doing this multiplication by 2x minus 3. So then for here you have 2x minus 3, and you will cancel off this, and you have 2, 5, 10x plus with 2 times 1, you have 2, right? So this is already cancelled off, minus with 5 times 2, you have 10x, right? 10x and plus with 15, right? Plus with 15. So of course then here you have 3 minus 3, 0. 15x plus 2x, you have 17x divided by 10x minus 10x, 0. 15 plus 2, you have 17. So 70 cancel off and you produce x. This is what we want, right? So then you know that your FGX have produced X, right? Okay, to double confirm whether this is, so I'm going to do the other way. Means that if this is happen to be, this is the very powerful result. Okay, you can very sure that these two will be the inverse of each other. Okay, this is also happen to be the same if you do for G composite the fx. Means that G fx, so G fx, so you will be putting the fx into your G. Your fx will be 3x plus 1 over with 2x minus 5, and you're taking this put into the G, so which is 5 plus 1 over with 2 minus 3, right? So you're going to put this one into the G here, the x here. So it will be 3x plus 1 over 2x minus 5, 3x plus 1 over 2x minus 5. So the same thing I'm going to do here is how to simplify this one. You multiply, this is a fraction, right? You can multiply up and down by a same number. So here I multiply by a same linear factor here. So which is 2x minus 5, right? 2x minus 5. So you're going to multiply inside. This one will cancel off with this one. Remember, cancel off. So you will have 5, 3, 15x, right? Plus with 5 times 1, 5. Plus with 1 multiplied with 2x minus 5. Okay, everything will become linear. And this one also, you multiply inside. This one will be cancel off. Cancel off. You have 2, 3, 6x plus 2 minus with 3, 2, 6x plus 15, right? 3, 2, 6x plus 15. Then you see 15 plus 2, you have 17x, right? 17x. And 5 minus 5, you have 0. And here you have 6x minus 6x is 0. 2 plus 15, 17x. You're still getting x, right? Means that FG x, you're getting x. And GFX, you also getting x. This clearly show that this follow these rules. So this only can happen if F and F inverse, the composite of F and F inverse, or the F inverse and Fx, only this can produce the x, right? Can produce x. So from the result here, I know that G is the inverse of F. Means that this could be your G here. So means that FGX equals to x. Means that G could be the F inverse, right? Or I can say F could be the G inverse, right? So it means that they are inverse to each other. So very simple. As long as you get FGX equals to x or GF equals to x, they will follow these rules here. Follow the rules here. So I can, if the question asks you to deduce, I can actually say that. I can actually state that. Okay, you see, your Fx is 3x plus 1 over with 2x minus 5, right? And your Gx is 5x plus 1 over with 2x minus 3. So I can say that your F inverse will be your Gx, right? Because Fg produce x, so G will be the inverse of x. So which will be 5x plus 1 over with 2x minus 3. Means the F inverse, you can straight away deduce the F inverse from the result here. Or you can say the G inverse will be the Fx, because they are inverse to each other. Means the inverse of G will be the F. Okay, the F. So which is 3x plus 1 over with 2x minus 5. Right? As simple as that. So this is a very important result. So once you get the composite to be x, then this means that the G is the inverse of F, or you can say that the F is the inverse of G. So therefore, this question is stating correctly. They said determine whether the function, the fx and gx are inverse of each other by computing their composite function. So in this video, I'm talking mainly about the properties of one of the properties of inverse function. Alright, that's all for this video.